what is your favorite number?
I'd have to go with 5.
5. Chinun, what's your favorite number?
3.
3. Good. How about Peter?
7.
7. And Yeonjing?
2.
2. And Scott?
9.
9. Okay. So how can you sort this number by increasing order?
Highlight.
In here must be lowest number 2, right? And then
3.
3, 5, 7, 9. Oh, good students. Anyway, we can do it very intuitively because we are human beings. But for computers, they must have a general rule to do it like this. So I'm going to introduce this kind of algorithm for today because yesterday I watched some lectures from some university. This was so inspiring to me because it gave me some idea that how to solve some problem is more important than what you have itself. It is more important than your property, your money, or your position, or your status. The way to solve the question or how to think is more important. So I'm going to share this idea with you. Okay. In 20th century, the computers developed very dramatically. Someone might know that this computer is called ENIAC. You know that it's very huge and it is composed of more than 70,000 capacitors and resistors or some whatsoever. But their performance is not very good. Actually, I don't know this person, but one of the inventor for this computer, one of the inventor is von Neumann, very famous mathematician. Actually, he's better at calculating than this machine. How many of you this computer called Aladdin? In my elementary school days, I wanna really have a Ipalyu PC computer, but nowadays it's just like a trash, you know. And these computers are very recent one. These are like hand-based computer. You can pull it and then you can use it as a computer. But this is very little, tiny and fancy looking, but their performance is far better than this one or even this one. So, however, there are hardwares, there must be some softwares to sustain this performance. Actually, this kind of very powerful performance machine cannot outrun this machine without better software or better algorithm. I'm telling you how come. Okay, getting back to the sorting the numbers again. I'm going to introduce 2 algorithms for sorting. This one is hard to see, but yeah, insertion sorting. This solution is very intuitive. You can see that we should rearrange this number by an increasing order. You start these 2 numbers and find its position. Number 2's position should be first, and after this row, you should consider this number 4's position. 4 should be between 2 and 8. For the number 9, it should keep its initial position, and number 3, it should be between 2 and 4, and something like that. So in this algorithm, we should calculate x squared times. It is hard to understand, but you can just feel, because we should consider this position, this position, this position. So we should consider 6 positions, and considering this position for 6 rows, so 6 multiplied by 6, so x squared times. This algorithm is just a little bit complicated than former one. But you can see these two columns are very well sorted. But consider all the numbers. You can just comparing these bottom numbers. You can sort all these numbers. Compare 2 and 9, you can get 2. Compare 7 and 9 and 7. Compare 13 and 9, you can get 9. So in this order, you can find very sorted numbers. So these are how merge sorting works. So these are the number arrays. You should chunk those numbers into two parts, and then chunk it until it became individual numbers. And then you should learn this method. Compare those two sorted numbers. So compare these two numbers, you can have sorted these numbers 27, 38, and sorted these numbers 3, 43, and then merge it again and again. Merge it, compare those numbers, merge it, and so it is really hard to get how its calculation should be log x. Log is a little bit difficult word for guys. You can see how it works by just looking those pictures. You can see that in merging algorithm, it looks like chunking and merging is performed again and again. So how merging is faster than insertion? I just follow a little bit. You can see if there are 10,000 data you should be sorted, then the calculation should look like this. So in that calculation, just believe me, merging is 10,000 times faster than insertion. Then how about consider this question? There are 6 billion populations in this world. We should sort them by their height. So our input data must be 6 billion. Then merge algorithm is 30 million times faster than insertion algorithm. It means that if this machine is faster than 30 million times faster than this old one, yeah, maybe not. Maybe not, absolutely not. It is not faster than 30 million times faster than this machine. So in this story, what I want to say is software or algorithm is much, much important than hardware or something. So in our old saying that it's better way to teach your child how to fish, all right? How to fish, not giving them just a fish or fishing rod or whatsoever. So that's it. Yeah. Thank you for listening.